Hi, welcome to Concept Based. I'm John Hepworth, and this is a Year 11 extension topic, further trigonometry. We're specifically in further trigonometric equations. And the previous video I did was talking about auxiliary angle questions, and we've got a little bit of time in the scope and sequence. I'm in week 5 in 2026 here. At the end of, we're in term 2 in week 5, and that scope does go to the end of this week. So I just wanted to do some practice questions essentially. So I'm actually using the sample HSC paper that NESA have provided for Extension 1 students. And I just wanted to look at a multiple choice question. And I wanted to look at this multiple choice question for a couple of reasons. One of those reasons is strategies, and another one is time. Because there are different strategies you can use to solve this question, and they will take a different amount of time for each one. So you have to consider sometimes in a multiple choice question what your strengths are, and therefore a way in which you can solve this question most quickly. What I'm going to do in this question is actually do it exactly in line with the way that I taught in the previous lesson on how to do these types of questions and demonstrate how it can be done that way. Then I'll do it a completely different way. Okay, so we've got a question here. Now I'll just show you the question from the paper so you can see what I'm talking about of being multiple choice. I've shortened the question to make it just more specific about what's actually being asked. And in the question, you're given 4 graphs as a response that you're picking from in the multiple choice. So that's why my question's written like this. Which curve represents f of x equals negative a sine x plus b cos x, where a and b are both greater than 0? So first of all, you've got to recognize that. So a is greater than 0 and b is greater than 0, but it's written as negative a sine x plus b cos x. So we're looking at a negative sine function because a is positive, but it's negative a in the f of x, and then b cos x. All right, so what we can then do is we can do the auxiliary angle. And the thing is we're not asked to put it in any form, so we can just choose whatever form we want to put it in. Now, again, if this is, if you have strengths in certain areas of expansions of these types of forms, then you use what works for you because you can use any of the 4 forms. But I'm just going to use essentially the first form because I'm fine with doing it in any form. So I'm just going to stick with the first form that we see in auxiliary angles. So I'm going to change it to the form r sine x plus alpha. Okay, so I've shown you that to do the way to do it is we expand that sign, and hopefully you're starting to remember these expansions of sums and products of angles. Again, they're on your formula sheet, but if you can go fast in an exam, then you have more time to do the harder questions. So hopefully you're starting to remember that this is sine x cos alpha plus sine alpha cos x. Now we're going to go and match up terms again. So we can see the sine x matches up with negative a up there. So we can say r cos alpha equals negative a. And then our r sine alpha is matching up with positive b. So because that's the case, we now know which quadrant this angle's actually in. So cos of the angle is negative, so it's not in the first quadrant. And it's also not in the fourth quadrant, but sine is positive. So that happens in the second quadrant, just here, right? So we know that alpha is in the second quadrant. So when we're considering what this r sine x plus alpha is, it's this alpha bit that's important here. So if I was just to go and graph any random sine function, r sine x, let's say. So let's just graph r sine x. So r sine x looks like this. Probably could go on the negative side as well because that's what the multiple choice answer questions have. So this goes up to a height of r. And then I need to consider what happens as this alpha changes. Now in my function, my alpha is positive. So any increase in alpha is actually going to move my function to the left. And the question is, well, how far does it move to the left? Well, we worked out that alpha's in the second quadrant, which is in this quadrant here. So I'm just going to pick some random place in this quadrant, and I'm going to move my graph left so as that point moves to the origin. Now, again, that could have been anywhere in this area that would happen, but we're just after a graph where we just have an example of it to see if it matches up with a multiple choice. So if I move it to that point that I've indicated, this point right here, then the graph is now on a downslope, and this is the point I was talking about. And then we go through and back up like this. So this is still at height R, but we come through below R at that position right there. So now if I go and look at the multiple choice solutions that were available to me, I can see that there's one of them where it goes through the y-axis at a positive place. So again, this is my graph that I've built. It goes through the y-axis at a positive place and then it heads down. And on the examples that are given for solutions, only two of them go through the y-axis, B and D, and only D goes through the y-axis and then heads down. This matches the graph that I built perfectly, so therefore I know that my multiple choice answer is going to be answer D. Okay, so that's, I would say, the most algebraic way of solving that question. But I have another way of solving this question as well, and that way is graphically. Now, I definitely want you not to look at this solution and go, oh, I don't need to know how to do expansion of auxiliary angles and so forth, because I know how to do graphs. No, no, no. You definitely need to know how to do the expansion of auxiliary angles because you need to get specific answers in specific contexts. But in this context, the question is saying negative a sine x. Now I'm going to graph a negative a sine x. So sine x usually goes like this, and I need the negative of that, right? So negative a sine x goes like this. Now I've made it dotted because I'm going to do two graphs. I'm also going to do b cos x. Now cos x normally goes like this. Where am I going through the thing? Here I am, like this. So I'll just dot that one out. Now you'll notice I've made it slightly bigger than the sine one. And that's just to remind me that these A and B values are just, they could be anything, right? They're any positive value. So I've got these two graphs here. Now there are important parts of these graphs that give me information. And the part that I really care about in this graph is just the start. The start for cos is starting at its apex. And sine, or negative a sine x, is starting at 0. So the real graph that we're going to end up drawing is going to start at the cos apex because 0 plus the cos value is the cos value. And now what's going to happen to the graph? Well, cos starts to go down and negative sine starts to go down. So my graph is actually coming through here and going down. So all I've drawn here is just this micro part of this graph. It's on the y-axis at a positive location, and my graph starts by going down. And that's enough to answer the question. If I go back to my multiple choices, I've only got one of 4 that goes through positive y, so that's B and D, and goes down initially, and that's D. So you can see here in my solution, I have done very little trigonometry. I've just graphed sine and cos. I've done no auxiliary angles. I've done no expansions of sums and products. I've just graphically put two things together and been able to come up with an answer here that this is answer D. Again, so what strategy do you use? Well, that's very dependent on what you are strong in. Okay, if you are really strong in algebra, in this analytic process, then probably stick with the algebra. But if you're really good at graphing, then the graphing process is probably going to be better for you here. My whole page is called concept based. And the idea for me, as I've said in many of my past videos, is that if you want to be able to do trig well, you need to be understanding the unit circle, you need to be understanding the graphs, and you need to be understanding the triangle. In this question, the graphs just immediately lead to an answer. So if you really do understand graphs very well, and you are conceptually sound in trig, then being able to answer this question the way I just did there, the second option, is probably the fastest way. But don't lock in, just work on what is best for you in terms of those ideas. And if these graphs were more complex, then sure, it might have been better just to be analytical. But in this example, we definitely can just go ahead and not have to do an auxiliary angle part and use additional time. Just do some quick dotted graphs and we're done for this multiple choice question. Remember, it's only worth 1 mark this question, so if we can make it as fast as possible, then that's definitely to our advantage.